Breaking news from SpaceX's Starbase. In a dramatic turn of events during Starship Flight 6, what began as a routine test flight quickly evolved into one of the most talked-about launches of the year. The world's most powerful rocket, standing an incredible 400 feet tall, faced an unexpected challenge as SpaceX attempted something never before seen in the history of spaceflight: catching a massive rocket booster with mechanical arms nicknamed chopsticks. Just weeks after their groundbreaking precision landing, SpaceX and Elon Musk pushed the boundaries once again. But this time, the ambitious plan to catch the super heavy booster took an unexpected turn. As millions watched worldwide, SpaceX made a critical decision that would send ripples through the aerospace community. Adding to the day's intensity, former President Donald Trump made a surprise appearance at Starbase, marking a remarkable convergence of space innovation and political interest. This unusual combination of events raised crucial questions about the future of space exploration and public-private partnerships in the aerospace sector. Today on Elon Musk 24 Hours, we'll take you through the exact sequence of events that unfolded, explore why SpaceX had to abort their revolutionary catching attempt, and reveal what Elon Musk himself had to say about this historic moment. Let's dive right in. On November 19th, as the sun rose over SpaceX's Starbase facility near Brownsville, Texas, the atmosphere was electric. Engineers and technicians moved with practiced precision, preparing for what would become one of the most watched launches in recent history. The Starship system, towering at 400 feet tall, stood like a gleaming silver sentinel against the Texas sky. At precisely 5 p.m. Eastern Time, history began to unfold. The roar of 33 Raptor engines shattered the calm, releasing an earth-shaking 16 million pounds of thrust. This wasn't just another test flight. This was SpaceX attempting to push the boundaries of what's possible in rocket technology. All systems are nominal, came the call from Mission Control. The world's most powerful rocket began its graceful ascent, painting the sky with a brilliant plume of fire and exhaust. But what made this launch truly extraordinary wasn't just the ascent. It was what SpaceX planned to do next. In a feat that sounds like science fiction, SpaceX had designed a system to catch the massive, super heavy booster using mechanical arms nicknamed chopsticks. Picture this: a 230-foot tall rocket booster weighing as much as a small skyscraper, executing a precise aerial ballet before being plucked from the sky by giant mechanical arms. This wasn't just ambitious, it was revolutionary. As the Starship spacecraft separated from its booster, tension in Mission Control reached its peak. The separation occurred flawlessly, but then something unexpected happened. SpaceX's flight director noticed anomalies in the critical communication systems between the booster and the tower. Dan Hoot, SpaceX's spokesperson, later revealed the complexity of the situation. The return and catch of the super heavy booster requires perfectly synchronized systems on both the booster and tower. We needed healthy communication links, precise positioning data, and optimal weather conditions. Most importantly, we needed absolute certainty about safety. What many don't realize is that catching the booster isn't just about the mechanical arms. It's about an intricate dance between multiple systems. The booster must calculate its position to within centimeters while traveling at incredible speeds. The tower must provide ultra-precise GPS-like guidance. The mechanical arms must move with millimeter precision, all while accounting for wind conditions that can change in seconds. Inside Mission Control, screens displayed a cascade of data. The booster's navigation system was struggling to maintain the required precision for a safe catch attempt. The decision had to be made quickly: attempt the catch with compromised systems, or abort to a water landing. In a moment that demonstrated SpaceX's commitment to safety over spectacle, the flight director made the call: abort the catch attempt. The booster, responding to new commands, adjusted its trajectory for a water landing in the Gulf of Mexico. But this wasn't a failure. Far from it. Jessica Anderson, SpaceX's manufacturing engineer manager, put it perfectly during the live broadcast. Development testing is unpredictable by definition. Each test, whether it goes as planned or not, provides invaluable data that moves us forward. The data revealed fascinating details about the challenges of catching a rocket booster. The communications system between the booster and tower needs to process positioning data faster than a human can blink. The mechanical arms must compensate for the booster's momentum while avoiding any sudden movements that could damage the hardware. It's a problem that pushes the boundaries of both engineering and physics. What makes this even more remarkable is the short turnaround time. This flight came just 1 month after the previous test, a dramatic improvement from the usual months-long intervals between launches. SpaceX is not just testing rockets, they're revolutionizing the pace of space innovation. Adding another layer of intrigue to the day's events was the presence of former President Donald Trump. Having flown to Texas specifically for this launch, Trump's arrival marked a unique intersection of space technology and political interests. Honored to have President Donald Trump at our Starship launch, Elon Musk posted on X, highlighting the growing importance of private space ventures in national policy discussions. During a recent campaign speech in Wilmington, North Carolina, Trump had urged Musk to accelerate the Mars program. Get those rocket ships going because we want to reach Mars before the end of my term. This statement underscores the increasing alignment between private space innovation and potential government policy. The implications of this test flight extend far beyond a single launch attempt. Each test brings SpaceX closer to their ultimate goal, making humanity a multi-planetary species. The Starship system isn't just another rocket. It's potentially the key to establishing human presence on Mars, revolutionizing satellite deployment, and transforming long-distance travel on Earth. The data gathered from this flight, including the aborted catch attempt, is already being analyzed to improve future missions. Engineers are working on enhancing the communication systems between the booster and tower, refining the mechanical arm response times, and developing more robust navigation algorithms. SpaceX's approach to innovation continues to break new ground. While the Falcon 9 rocket, with its 370-plus successful booster landings, has become almost routine, catching the super heavy booster represents an entirely new level of complexity. It's the difference between landing a small private plane and catching a jumbo jet in midair. The presence of Trump at the launch site sparked discussions about potential changes in space policy. Industry experts speculate that increased government support could accelerate SpaceX's ambitious timeline for Mars missions. Musk envisions uncrewed Starship missions to Mars by 2026, with crewed missions following during subsequent Earth-Mars alignments. Behind the scenes, SpaceX teams are already implementing improvements based on Flight 6's data. The communication systems are being upgraded with more robust protocols. The mechanical arms control systems are being refined for faster response times. Each adjustment brings us one step closer to the day when catching a massive rocket booster becomes as routine as landing one. As we've seen today, SpaceX's journey to revolutionize space travel isn't just about the successes. It's about learning from each challenge and pushing forward. While the booster catch attempt may not have gone as planned, it represents another crucial step toward making humanity multi-planetary. The presence of political figures like Donald Trump at these launches signals a growing recognition that private space companies are reshaping our future in space. SpaceX's decision to prioritize safety over spectacle during Flight 6 demonstrates the maturity and responsibility that will be essential for future Mars missions. As Elon Musk often says, the first step to solving any problem is recognizing there is one. Today, SpaceX didn't just recognize the challenges, they showed us how to face them head-on. The next Starship launch will build on these lessons, bringing us closer to the day when catching massive rocket boosters becomes routine, and Mars feels a little bit closer to home. If you want to stay updated on the latest developments in SpaceX's groundbreaking journey and Elon Musk's vision for the future, make sure to subscribe to Elon Musk 24 Hours. Hit that like button if you found this analysis insightful, and share it with fellow space enthusiasts who share our passion for innovation and exploration. The final countdown to Flight Test 6 is on, and this could be the most significant launch yet. In just days, we might see this engineering marvel take to the skies again. The pace of progress at Starbase is absolutely incredible, with critical preparations happening around the clock. The week kicked off with an impressive deluge test, a massive water suppression system designed to protect against the colossal forces of 33 Raptor engines at liftoff. This advanced system channels an enormous volume of water through the stainless steel flame deflector beneath the orbital launch mount. In an unexpected move, the final Block 1 Starship rolled out first, featuring fascinating modifications including strategic heat shield changes that could revolutionize future recovery operations. Its powerful booster partner followed shortly after, and now both vehicles stand united at the launch site, ready to make history. The excitement doesn't stop there. The Falcon 9 program continues breaking records, while construction on the second orbital launch site progresses at an astounding rate. We're witnessing space innovation at an unprecedented pace. Welcome to Elon Musk 24 Hours, where we bring you the latest and most exciting developments in space exploration. The anticipation is building for what could be the most ambitious Starship test flight yet. Let's dive right in. The preparation for Flight 6 represents the culmination of countless engineering innovations, each more impressive than the last. At the heart of these preparations, the Deluge System stands as a testament to SpaceX's commitment to safety and efficiency. This isn't just any water suppression system. It's a precisely engineered network of water channels integrated into a massive stainless steel flame deflector. During recent tests, the system demonstrated unprecedented water pressure levels, suggesting significant upgrades from previous configurations. Why such attention to water suppression? The answer lies in the raw power of 33 Raptor engines firing simultaneously. At liftoff, these engines generate acoustic forces capable of causing structural damage to both the launch pad and the vehicle itself. The Deluge System's role is twofold. It suppresses these potentially destructive acoustic waves while simultaneously protecting the launch deck from extreme heat exposure. Engineering calculations suggest that redirecting this massive water flow toward launch operations, rather than reserving it for booster landing, maximizes the system's effectiveness. While Flight 6 preparations continue, a parallel narrative of innovation unfolds at Launch Site B. The construction team has achieved remarkable progress on the culvert system, a complex network designed to transport vital commodities to future vehicles. This engineering marvel is being constructed in carefully planned stages to maintain uninterrupted access to the active launch pad, a crucial consideration given the imminent flights of Ship 31 and Booster 13. The flame trench construction has surpassed all expectations, with recent aerial photography revealing the installation of primary propellant lines within the culvert system. The newly implemented drainage systems have proven remarkably effective, eliminating the previous challenges with water accumulation. This achievement marks a significant step forward in launch site reliability and operational efficiency. The second launch site's Mechazilla Tower represents